Welcome to the data preparation phase. In this video, we'll learn how to partition data, balance data sets, and build various decision trees models in Python. So, welcome to data preparation phase. In this video, we'll learn how to partition data, balance data sets, and build various decision trees model in Python. So, the data preparation phase involves transforming raw data into a format suitable for analysis and modeling. This ensures that the data is clean, organized, and optimized for machine learning or statistical model to deliver accurate and meaningful results. So, first we have how to partition the data using Python. So, partitioning the data is the process of dividing a data set into distinct subsets, typically training, validation, and test data. So partitioning data is essential for creating robust machine learning models. So in Python, partitioning can be done using sklearn model selection.train test split. So let's see how it's done in Python. So here is the code. So first we will import train test splits from sklearn model selection, and then we will import pandas. So next we will create a sample data, then we will perform partitioning the then we will do the partitioning the data. So for x, data is features, and for y, data target, x train, x test, x train, y test, y train, y test, and train test split. We will split the data, and then we will print the output. So let's run the code. So here 80% of the data is used for training and 20% is reserved for testing. Partitioning ensures the model generalizes well to unseen data. So up next we have how to balance the training data set using Python. So balancing the training data set is crucial when dealing with imbalanced classes where one class significantly outnumbers the others. Imbalanced data can lead to biased models. So imbalanced data can bias your model, but we can fix this using oversampling or smooth. So common techniques include oversampling that duplicate the examples of the minority classes, then undersampling that remove examples from the majority classes, and that smooth a synthetic minority oversampling techniques that is generate synthetic samples for the minority synthetic samples for the minority class. So here's an example. uh, so here so first we will import smooth from learn oversampling. So then we will import pandas, and then we will sample imbalanced data set. So here we will create a data frame, and then we will do balancing using smooth, and then we will print the output. So let's run the code. So here we have the output. Balancing ensures each class is equally represented, making the model fairer and more accurate. So up next we have how to build cart decision trees using Python. So cart is classification and regression trees. A decision trees use binary splits to classify or predict data. They split features into decision nodes based on criteria like Gini index or entropy for classification and mean square error for regression. So decision trees are intuitive models that split data based on conditions. So let's build a cart decision tree using Python. So first we will import decision tree classifier from sklearn.tree. Then we will import load arrays from sklearn.datasets. Then we will load the data. So we will then load the arrays datasets that we have used. So then we will build cart decision tree using cart tree decision tree classifier, and then we will print the output. So let's run the code. So here tree built with Gini index. So decision trees, cart trees split data into groups with similar target values, creating a imprintable model. Next we have how to build C5.0 decision trees using Python. So C5.0 is an advanced version of the C4.5 algorithm that builds decision trees for classification tasks. It offers better performance and smaller tree sizes, while C5.0 is not natively available in Python. You can use third-party libraries or tools like sklearn with similar methods. So C5.0 improves classification performance with smaller and faster decision trees. While it's not directly available in Python, let's mimic it using an entropy based approach. So first we will import decision tree classifier from sklearn, then we will import load arrays and from sklearn.datasets. Then we will load the data, and then we'll build decision tree that is similar to 5.0 using entropy. So here let's run the code. So here tree built using entropy similar to C5.0. C5.0 decision trees excel at classifying complex datasets while being efficient. So up next we have how to build random forest using Python. So random forest is an ensemble method combining multiple decision trees to improve classification or regression accuracy. Each tree is built using a random subset of the data and features, and the final prediction is based on majority voting or averaging. So random forests are powerful models that combine the strength of multiple decision trees. So here's how to build one. So first we will import random forest classifier from sklearn.ensemble. Then we will import load arrays from sklearn.dataset. Then we will load the data in arrays datasets. Load the arrays datasets, and then we will build random forest. So up next we will print random forest built with 100 trees. So when our code will be executed, so let's run it. So it is printed that random forest built with 100 trees. So random forests handle overfitting better than individual trees and are robust against noisy data. So in conclusion, data preparation ensures that your machine learning models are accurate and reliable. These technologies lay the foundation for successful modeling. Thank you. I hope you understood the topic.